Hello, everybody. This is Lars, your developer and consultant from PDV. And in the last Rock and Code session, we already teased that we are going to code with you a freight exchange use case. You already saw where it will end up, and today we code it step by step. So I already started here to create the basic frame of our project, and I already started with an index TSX file. And now we start with just writing our interfaces. So it's a huge application, and we need many data types. And so I just try to copy and paste it. So you see, we will have a transport leg. We will be able to set the transport leg. We have a bounding box for the geometry where we want to simulate our orders inside. We have the transport opportunities, and we also want to check if they are valid, if they are inside that bounding box. And we also have the transport opportunity selected, and we have the transport relation. So that's our basic data type, and we share these data through the whole application. So we do not want to have block drilling. We use a context provider. And that's the main idea of that application context. And furthermore, we want to share that application context, and therefore we have to create it. So that's what I'm going to do just one line above. So we create the context. Later, we import all the necessary libraries for that. And we just type that create context function with the application context data or with null if we have no data inside, if we just start the application. And now we are going to start the basic component, the home component. So then export default function, let's call it home for our main entry point. And there we use several state hooks in order to maintain that state. So what we have here is just a use state hook for the transport leg and a possibility to set the transport leg. We have a possibility to set the bounding box, to set the valid transport opportunities and the invalid ones, the selected transport opportunities, and also the transport relations. And all those then are the base for the application context. So that are the use state hooks as we used it in the previous sessions. That should not be something new. And now we just create our application context according to that interface that I have just shown. So what we have here is an object that has the type of that interface. So here you see the transport leg is initialized with a transport leg hook, and the same with the bounding boxes, and the same story with the relations and with the transport opportunities. And then we have the basic rendering function. So let's just add it here after the application context. And what we are doing here, we have the application context provider. That's where we hand in the global application state for the whole application. We also hand in a vector map component that we create in a few minutes. And we also have that KPI column that shows the occupied kilometers and the empty kilometers. And that's it, what we need for our basic frame. And now I just add the import statements for that functionality. So let's take a short look at this. So we have feature collection and the feature from the GeoJSON library. That is the library we use for rendering all that lines and the markers. We also have the create context hook for the application context, the use context and use effect hook, and the use state hook, as we did in the last sessions. And we also import some functionality from the KPI column component and from the vector map. So we did not code it right yet because that's why it is actually red. And that's what we are going to add now. But before we are doing this, you have seen in the intro video in the last session that we have several kind of markers. So we have a yellow marker, we have a green marker, we also have an orange marker and a red pin. And I just copy and paste the first marker and explain it so that you have a basic idea how it looks like, and the other markers are just the same story with a slightly changed color. So here we import from React the necessary components. We have an icon, so that is just a path description of a scalable vector graphic. And then we have a pin style. So the pin style is cursor pointer, and we have a certain fill color. And for that green pin, it's the color green. And then we just wrap it into a React component. We have here the SVG, and we just hand in the path description, and we also set it to a default size of 20 pixel, and that we do not re-render it each time we use a React memo function. So that is a green pin, and now I can also just add the gray pin and the red pin and the orange pin and the yellow pin. So let's copy and paste it and let's add it. And as you see here, this is the gray pin, and when we look at the orange pin, it's all the same structure. You could also just make a generic component out of it and hand in the color. For simplicity reasons, I just created each component on its own, and now we have the markers for our map. And now the next step would be to create a new component for that KPI card column. And therefore we need a new file. Let's call it KPI column.tsx. Let's create it. And I just copy and paste the content, and we go just through it. So what we need here is that we have to add as a reference the application context. That's the global state provider, and we consume it here with a used context hook. That used context hook is imported here. And then we have here several divisions, and these divisions, as you can already see on that heading, distance occupied, distance empty, and distance empty original, that's just the mark out or markup for those KPI cards. And as we did in the last videos, we are using Tailwind as a CSS library to make our life easier. And we just have here some declaration like rounded large edges, and some padding and some styling, some justify between, some background information. So that's all Tailwind that is doing that for us. And then we add the heading distance occupied, and here you see that we are using the application context, and we are going into the transport leg, and we just look at the occupied distance. If it is not set, we have 0 kilometer, and otherwise we just take the existing value, we do some rounding that we do not have too many decimals, and then we just add the kilometer unit. And the same story is true for the distance empty. You could also wrap that inside an own component. Just for simplicity reasons, I copy and pasted it here, but here you have the distance empty, and you would just look at the certain empty distance attribute in the application context. And the same is with the overall distance. And that's how that a KPI column component looks like. So just a little bit of CSS magic and consuming the global context, and you are done. And now we can add some helper library that basically includes all that routing calls that we did to the PTV developer API, the optimization calls. So it's somehow a summary of all the things we learned in the last sessions. So let's start it, and many parts I'm showing should be familiar for you already. So let's call it helper.tss, and let's go step by step through it. So it's a huge amount of code, but I just explain it step by step. So what we are doing here, we have an API key. So do not copy my key. It will not be working after this recording. And then we have a calculate route function. It's an asynchronous call to the API, and we are handing in a pickup location longitude, pickup latitude, and delivery longitude and delivery latitude. They are all numbers. And then we are using the API of PTV developer, here just some GET request to the GET endpoint. And we use the promise syntax, so we do not have that callback hell, so we just have here an await fetch, and we await the response. And we inject also the API key to be able to communicate with the PTV developer endpoint. And then as soon as we have that response, we are converting it into a JSON, and then we have our result. And here for the routing, what we are doing, we are then just generating, so we are just generating a random location for our freight exchange simulation. That's a function that you see later in the code. It's an asynchronous function as well, and you await it. And then you just fetch the response, and you do that as long as you have non-valid routing. So if we just throw random coordinates into the map, the United States are a country that is not populated in a very dense way. So it is very likely that with random numbers and coordinates, you just end up on some mountain, and that we do not want to have. So that is why we just check if those simulated coordinates are really valid and if they are somehow accessible from the street network. And that's the main idea of that calculate route function. And here we have a reverse geocoding function. We also looked at this in some previous videos, and we just hand in longitude and latitude, and we do a reverse geocoding, and then we get the result, and we get back the locations object. Then we have the function generate a random location, and here I just create a random point inside some bounding geometry. So when you remember, we had that gray box for that simulation of the transportation legs, and these are just the corner points of the gray box, and inside that gray box we simulate with the turf library random points. Then we do a reverse geocoding, and that's a function that we just explained here, and check if everything is valid, and we do that random number generation as long as the result is not valid until we have a valid one and can use it for our simulation. Then we have here the optimize function. It's again an asynchronous function, and we give in transport opportunities and transport legs, and we give in just some setter function for the selected transport leg. And we also hand in the setter function for the distance occupied to update our KPI cards, and also for the final result distance. Then we just filter out from the transport opportunities those that are valid, and then we copy it to that transport to consider array. We set up a locations array in a local way, and then we push the starting location of our long haul transportation and the end location. Both are depots. And then we just loop over the transportation to consider function array. And we just add pickup and delivery location to map those contents to the suitable structure of PTV developer. So we need an ID, we need some quantities, and we also need the pickup location ID and the delivery location ID. And the same with the drivers, we just loop over the transports to consider, and for each transport there is a suitable driver, and we just hand here in the ID and use string interpolation to hand in the index. And we also use the working hours preset to for multiple days to have the driving and rest times available, the legal regulations for the US. And we set some maximum travel time of the travel time we would need for the direct connection from start to the destination, and in order to pick up on the way some additional transport, we allow some kind of detour factor of 2. That could also be some arbitrary number that just suits your use case. And then we have the drivers, and each driver has a vehicle, so we also do the same story with the vehicles. We have some additional restrictions, so we only want to have a single trip per route, and we do not want to have a single depot, so we set that to false. We just define some planning horizon that could also be handed in from the Excel import or from some text box in your web application. And then we finally build the route optimization request that has all the ingredients of the locations, the transport drivers, and so on. And then we can finally send that request to the route optimization endpoint, and we create here the plan. It's a post function, and as we have seen in the previous request, we need that header with the API key, and we just stringify our route optimization request object, and then we are fine to send it. And what we get back is a plan result. So we again use promises to await it. So we get the plan result. And then we can also fetch for the plan. So we constantly have to poll for the status, and we use the plan result ID that we got from the initial creation of the plan. And then we set the status to running. And then we implement here some long-term polling, and we just ask in certain intervals for the status of our calculation. And as soon as this status is succeeded, then we just break out of that loop, and then we can fetch the plan. In order to fetch the plan, we have a GET request, and we have to hand in the ID of the plan as well. And then we just transform our response to a JSON object, and then we just find out the longest possible transport in that plan, because in the use case, the customer requires that we should find the longest possible transport, because they just bill the prices to their customers with respect to the driven route. And that we are doing here. And then we are setting the distance occupied to that maximum that we found. So this loop just finds out the maximum distance that is possible for the best transport. Then we just set it for the global state, and automatically the KPI chart is actualized. Then we have the maximum route, and we just find out the location. And then we just want to display that way from our starting point to the pickup point, to the delivery point, to the end point. We want to show the routing polygon, and therefore we need a call to the routing engine. That's again a GET request, and we can just use with string interpolation our longitude and latitude coordinates, and just define the waypoints. And then we can use promises to get back that result and convert it into a JSON object. Then we want to update the transport leg. We just translate that routing result polyline into a GeoJSON object to be able to display it on the map. And then we just actualize the occupied distance and have the result distance, the overall distance, and just take the difference to distinguish the empty distance. And then we just add this new transport leg to our global state with a callback function set transport leg. And then automatically all that data are actualized in the global state. And here we have the final function, generate random transport opportunities, and we would just hand in the number of transport opportunities. So if we want to simulate 100 orders, or if we want to simulate 1,000 orders. And we have the pickup and the delivery location of the whole long-haul transportation. And then we just have here the loop to simulate the necessary transports. And here we just call the random location function, the calculate route function, and then we just calculate a bounding box and the bounding polygon. And finally, we set the random transport opportunities. We push here the new data. We use UUID, that's a library to create uniform identification numbers to be able to distinguish each of the transport opportunities. We have a start date, and we also set the travel times and the start and the destination location, and we set it then to valid. And then we return our random transport opportunities. Here we generate the rounding box, so we have the start and end location of the long-haul transportation, and we just use it as a base to calculate the bounding polygon. And here we generate the random transport leg and use the generated bounding box and just the calculate route function, and then we just export all that functionality from our helper function so that we are able to use it in other components. And here we somehow collected all the necessary function calls, and now we can use it in the vector map component. So let's just edit vector map.tsx. And let's investigate it step by step. So we have again the API key, we have a map style, we use a standard map style. We have a navigation control to zoom in and zoom out, that's usually on the top right corner. We have an initial view state that is somehow coordinate in the middle of the United States. And we set the zoom factor to 4, so that's not too deep zoomed in, so that you have somehow the silhouette of the United States in your initial map. And then we create the interface transport opportunity that has an ID, a start date, a travel time, a start and a destination location, and some state if it is valid or not. And then we have the transport leg with ID, start, travel time, the result distance, the occupied distance, and all that necessary information that we need for the KPI cards. And then we start the vector map. And we have here some use state hooks for the forward leg and the backward leg. So forward leg is the original transport from start to destination. And for the way back, you want to fit in the best possible transport that comes out of your freight exchange. And we also have here a use state hook to set the points and the markers. Then we consume the global application context. We have a reference to our map, and we just want to zoom the map according to the bounding box that we are doing with it on map load callback. And then we have the transport leg points. That is just a feature collection that we need to be able to show that GeoJSON values on the map. We have the bounding box points. We have the transport relations, and we also have for that line that displays the actual driven route, we have a fill layer with a certain color. Then we again have a point to marker callback function that we also used in the first video where we show how to use our vector map. And here I just add a marker. I use a unique ID to make the re-rendering easier for React. And we hand in latitude and longitude. And then we are just comparing if the color is green, we use a green pin. If we have a yellow attribute, you want to use a yellow pin, and so on. And that's how we create our marker, or how we transform a coordinate to a marker. And then we have the get transform request, where we somehow just add the header information for the vector tiles API, and then we have here just some function to show that everything is working, where we just write to the console the distance occupied. And then we have here our simulation function, where we generate the random transport leg, where we set it to the global state, and where we just push that transport leg points to our GeoJSON structures. We have the random transport opportunities, and we just add here some line strings that show which starting point is connected with which delivery point. Then we set it to the global context with a set transport relations callback. And then we just optimize the result and hand in all the parameters. And then we are fine to display everything. So we also add that simulation button. It's just a button styled with Tailwind. And it is an async operation because it's a long-lasting operation to calculate all that random points. And here we just add the optimized transport leg. And basically we have also that's line string. And that's what we do in this part of the button. And here you have then the text simulate freight exchange. Then we put everything together to show all the things we did in the map. So we are again using MapLibre. We have that onLoad event that we just connect with our onMapLoad function to just center the map according to the bounding box. We have the initial view state, we have some basic style, and then we add the navigation control with a navigation control style so that it is displayed on the upper right corner. We just want to show here with conditional chaining if the bounding box is available, we want to display it, and that we do just with a GeoJSON layer where we take the bounding box out of our global state. And then we want to show the green marker for the starting point, the red marker for the ending point of the long-haul transportation. And here we just show that yellow and gray markers according to their color attribute. Here we show the orange and gray markers according to their attributes. So if something is inside the box, it is yellow, otherwise it would be gray. And here we query our transporter relation, so we just access it if it is not null, and add some source layer, our line layer, to depict the transport relations. And then we have at the last point the routing polyline, and that's where we show the actual driven route on the road network. And there are the steps for our vector map. We export the vector map so that we can use it in the home component. We also export the types, the transport leg, and the transport opportunities. And so we are able to call here that basic component with a vector map and with a KPI column. And we just maximize it on the screen. And here is the place where we inject our global application context. And now let's look if everything is working fine. So I open a terminal. It's the freight exchange template. Let's try it. npm run dev. Server is starting. We need some time till everything is up. I could also open a new browser window, and then we should see very soon. Okay, yeah, let's go here to PDB Developer. So some advertising for our new website, by the way. So we did some new style to make it even more accessible for customers and to make it even more understandable. But we have a special video for that. And now I just want to open the application on our local host. And now we see an error is invalid. Okay. Add page. So it seems that I screwed something up, but let's just look at the final version. So it should now be displayed on some different port. And now soon in the browser window, we can look at the hopefully running version. Compiling, just need some seconds. And now you see here on the map, you see the United States, you see our KPI cards, you see the control on the up right corner. And when I now click to start the simulation, it needs some time because we will have many transports that are created randomly, but you already see the bounding box that we created. You see the start point of the long haul transportation and the ending point of the long haul transportation. And now step by step, we will see the orders that are coming in from the freight exchange. Here you already see that on the way back you would have empty distance from this point to that point of nearly 4,000 kilometer, and that we want to become smaller. And now just the orders are created. That needs some time because you need many random numbers. And if you connect to a real stock exchange, it will be faster. But just to make that use case visible for you, we simulate it. And here you see the starting points of the simulated freight exchange opportunities. And now you see here that we are picking up this order and transport it to this location. And that's the longest possible transport inside this bounding box within the bounding conditions that you are allowed to double your total distance only by factor 2. And you also see that you do not overshoot into the more western direction, and you do not overshoot into the more eastern direction, and that would be actually the route that you are driving. And you have now a distance empty of 2,200 kilometers. Before that, it was 4,000 kilometers, and your distance occupied on your way back are 1,890 kilometers. And so you just maximized your revenue on your way back to home. That was it for today. I hope you enjoyed that extended coding. And if you want, we can go on with more complicated use cases that really serve your need. And stay tuned. Do not forget to subscribe the channel, and see you in the next Rock and Code session. Bye.